All right, so this is the second of two videos where I'm solving systems of equations in three variables. And you can see this one's a little bit different. We're missing a z term in the first equation, and we're missing the x term in the second equation. So it might kind of throw you off as far as the steps we're using here. Now remember, our first goal, our first step, is to get two equations in the same two variables. So I want you to think about how you would accomplish that here. Go ahead and look at it and see if you can figure out a way that you can get two equations in the same two variables. And you may want to stop the video. I'm going to go ahead and talk about this or go through this. So I'm looking at the first equation, and I already have an equation in two variables, x and y. And so that's, and I'm going to go ahead and label the equations here. And then I'm looking at equations 2 and 3, and I'm noticing, I could probably work with equations 2 and 3 and eliminate z, which should result in an equation in x and y, or at least that's what I'm thinking. So let's go ahead and try that. So our first equation is equation 1, x plus y equals -4. And my goal is to get another equation in x and y. And so we're going to use equation 2 and equation 3. But notice I need a 3 here. And so I need to multiply equation 2 by 3. And so let's go ahead and do that. So it'll be 3 times y is 3y, and 3 times a minus z is a minus 3z, and 3 times 1 is 3. All right, and then let's write down equation 3. That's going to be 2x plus y plus 3z equals -21. So now let's add these together. Let's see, there's just the 2x term there of 3y and a 1y give you 4y. The z's do cancel, and we're left with -18 on the right, 3 plus -21. And so here's our, we've got another equation. We'll call this one equation 4. And let's rewrite it right below equation 1. And so now we can use equations 1 and 4 to solve for x and y. So we've accomplished our first goal of getting two equations in the same two variables. All right, so now I'm looking at this and I'm thinking there's not one way to do this, but I would say I would probably multiply the first equation by -2 so I can get a -2x. And then when I add the equations, I'll be able to eliminate x. So let's go ahead and do that. So we're doing the second step now. We're solving this system of two equations in the same two variables. So we're going to multiply equation 1 by -2. We'll get -2x minus 2y is equal to 8. And I'm going to rewrite equation 4 right below. And so let's add these together. The x terms cancel each other out. A minus 2y and 4y is 2y. And we're going to get -10 on the right. So divide each side by 2, you get -5. You can just do that one in your head. And now again, at this point, sometimes students get lost, but remember, we're just solving this equation here, this system of equations. We just found y, we need to find x. So I'm gonna use equation 1. I'm liking that one. We got x plus y equals -4, and y is -5. So basically, we have x minus 5 is equal to -4. And if we add 5 to both sides, we get x is equal to 1. And so we've found the x and y value. And so I'm going to write my ordered triple with 1, -5 for x and y, and now I need to find z. Well, I'm thinking, I could use the second or third equation. The first one doesn't help because there is no z. But I'm thinking equation 2 looks like a pretty easy one to use. Y minus z equals 1. Notice we're at step 3 now. We're trying to find our last variable. And we just said that y was -5, so we have -5 minus z is 1. we'll add 5 to both sides and get negative z equals 6. And that's going to mean that z is negative 6. And so let me go ahead and write that in. And again, we got a solution here. We have at least one solution that makes the system consistent, and it's also independent. All right, let's move on to the last problem. So I'm looking here, and actually I would encourage you to look at the variables and decide which variable you want to eliminate. So if you look at the z's, that's definitely the obvious choice here. I could add equations 1 and 2 and eliminate z. And similarly, I could do the same thing with equations 1 and 3. And so let me go ahead and label our equations. And notice I've made the comment here, I choose to eliminate z. This is a choice, not the only way to do this problem, but we're always looking for the easiest way. All right, so I'm going to go ahead and add equations 1 and 2 together first. This is, of course, step 1 of our process. We're trying to get 2 equations in the same 2 variables. So there's equation 1 and equation 2. And when I add those together, x and 2x is 3x. 2y minus y is a 1y. And we're going to get negative 8 and 4 is, well, the z's cancel, and we get negative 4 on the right side. Negative 8 plus 4. So we'll call this equation 4. And so now, remember, you have to use all 3 of the equations as you're solving a system of 3 equations and 3 variables. We used 1 and 2, so we need to use 3 now. So we'll use 1 and 3 together. Remember, the z's are opposites, so I'm just writing down equations 1 and 3 here. So let's go ahead and add these together. We already have opposites for z. We're going to get 9x plus 3y is equal to negative 6. And so we'll call that equation 5. And so we found our 2 equations in the same 2 variables. Let's put them, I'll put E5 or equation 5 right below equation 4. And now this is step 2 of our process. We're solving this system. Oops, excuse me for a second. Okay, let's finish things up here. So let's see, we have equation 4 and 5. We're going to go ahead and, let's see, I want to eliminate, it really doesn't matter x or y. Let's go ahead and multiply the equation 4 by negative 3. And so we'll get a negative 9x in that first spot, and that'll cancel out the 9x below. So we're going to multiply negative 3 times equation 4. Negative 3 times 3x is negative 9x. Negative 3 times y will give us a minus 3y. And on the other side, negative 3 times negative 4 is 12. And then let's just rewrite equation 5. And so when we add these together, we do eliminate x. And a minus 3y and 3y gives us, oh, we eliminate y too. So we're going to have 0 on the left. And on the right, 12 minus 6 is 6. So we say, or so we get 0 equals 6. Well, that's false. And so we know that when we get a false statement, that means there's no solution. And in fact, what that tells us here is at least 2 of these lines, and they're actually, because of the 3 variables, they're planes in 3 dimensions. And so at least 2 of them are basically the same. And so that's why we have infinitely many, I'm sorry, I said that wrong. They're all parallel, and that's why there's no common solution. Or at least there's 2 that are parallel. All right, so that means we're inconsistent since we don't have at least one solution. And this is not the dependent case. That would be if they were actually the same plane. So we're still independent. Now, if you had gotten a situation where everything fell out and you just ended up with like 6 equals 6 or 0 equals 0, that's the case where 2 of the planes are the same, and that's the case where we have infinitely many solutions. So that is your other special case. All right, so we're going to go ahead and end things right there. That's it for this video.